So looking at the notes packet, page 1, fundamental theorem of calculus, part 1. That is basically the antiderivative of a derivative is back to f. And then either top minus bottom or plus c, kind of depending on the problem. So we did a whole bunch of that stuff. Number 6, so this is, what is that, the third page? We're going to do that problem tomorrow in class. And then the next page is Fundamental Theorem of Calculus 2.0. That's the one where the derivative of an antiderivative gets you back to the original. And what's the caveat on that particular version of the fundamental theorem? What's that? I think I heard it. Chain rule. Chain rule off of whatever those limits were. We did all that on yesterday. So very back page. We'll continue the second part of the fundamental theorem, and then Friday we'll jump back and review the first part of the fundamental theorem, and then Monday, that way I'll leave Monday open for questions from worksheet 4. That way I don't have anything set to do except work lots of problems from worksheet 4. Okay, so very back page of the worksheet packet. The graph of a function f defined on -1 to 5 consists of a quarter circle, 3 line segments. Okay, so this is f, that's not f prime. And let g be the function given by the integral from 0 to x. Okay, I think, especially on a problem like this, it doesn't exactly say it, but my guess is it's going to ask me for g prime, or I'm going to have to use g prime somewhere. So I'm going to go ahead and find it right now, and because I think I'll need it later. So what's the derivative of the integral of f of t? Well, be careful, it's not f of t, it's f of x, and then chain rule is times 1, so that one's not bad. And then they frequently ask, so I'm kind of skinning the problems here. Find g of 0, relative minimum, so that will need g prime, or relative maximum, excuse me. Part C, relative absolute minimum, so that'll be g prime as well. And then part D, point of inflection, that'll be g double prime. So I may as well find g double prime while I'm up here. So what's g double prime? F prime. And I don't really have to say this, but just sort of note to self, f prime is the slope of f. I'm trying to give everything in terms of f. So g is the antiderivative of f, g prime is f, and g double prime is the slope of f. So now I'm ready to answer anything about g that they want to ask me. Values of g, increasing, decreasing, max and min, that's first derivative stuff. Concavity and inflection points, that's second derivative stuff. So now let's start the problem. So g of 0. Okay, so 0 goes in for x on the left. That means 0 goes in for x on the right. So the integral from 0 to 0. I propose I can answer the question right now. What's the integral from 0 to 0? 0, because that width is, there's nothing there. Like, I don't care what's on the inside here. That's got to be 0, because if these two things match, there is no integral. Or there is an integral, but its width is 0, so there's no area. g of -1, integral from 0 to -1. Yeah, I was going to say, I already don't like that. So let's flip it. Well, more specifically, what don't I like about that?
Because it's backwards almost.
Yeah, it's backwards. And it's... So, Preston, how do I fix... If I want to switch those limits around, because it's backwards, it's out of order.
Yeah, just flip them.
I do want to flip them, but what price do I have to pay, or what would allow me to flip them?
I don't know.
So I do want to make it -1 to 0, but how would I do that? Somebody help Preston out here.
You make it at the negative.
A negative out front would flip that order around. So the antiderivative f of t from -1 to 0. I keep saying antiderivative, but antiderivative is more for equations. Isaiah, I don't have an equation, I have a picture. So what's another way to think of this symbol? Antiderivative, but also...
Is that your question?
That's my question. What else does it mean?
Area.
Trey's trying. Did you know that before Trey said it?
It does.
I hope so. So the area from -1 to 0. Oh, that's nice. A nice little triangle. 1/2 base times height. So that area would be 1. But that negative's still out front, so -1. G of 2. Why don't you try G of 2? Okay with pi as an answer?
Yes.
So the area from 0 to 2 is pi. Why didn't I include 1 as part of my answer? Right, I'm going from 0 to 2. I don't care what's going on over there. Just from 0 to 2 is pi. And then lastly, G of 5. So the integral from 0 to 5. Well, 0 to 2 I already know. That would be pi. And then from 2 to 5, I have to split that up a little bit. That area is 1. That area is, I'm just going to count the squares. 1, 2, and those together make 3. So what's not quite right about what I've written so far? Why are they negative?
It's underneath.
Because it's underneath. So you can label them 1 and 3 because that's what the area is. Most people would label them with negatives since that's really the point of this. So pi -1 minus 3, which is pi minus 4, but safe stop. Make the grader do some work. Part B. Find all values of x on the open interval at which g has a relative maximum. Justify your answer. Let's see. Let's justify our answer first, because then we'll know what to look for. So a relative max of g is when g prime. All right, we should be able to answer this like in the middle of the night, woken from a dead sleep. What'd you say? Yeah, positive to negative. You just got to think about it each time. When g prime changes positive to negative, what's g prime equal to? Let's see, we already did that. G prime is equal to f. So f, that's the same thing. So when f changes positive to negative, at x equals so Kyle, looking at the graph, where does f change from positive to negative?
At 2.
At 2. Good. It's not hard, but you got to know what to look for. It's not where f prime changes, not where the slope changes, but where f actually changes from being positive to being negative. So at x equals 2 is our answer for a relative maximum, because that's where g prime changes from negative to positive, or excuse me, positive to negative. Part C, find the absolute minimum. Absolute is like flashing red lights to worry about what? Pardon? Critical numbers and endpoints. But especially the endpoints, because that's what people forget. Critical numbers and endpoints. Well, that was kind of them. They already gave us we already found a critical number, but that was a maximum, so I'm not really worried about x equals 2. So critical numbers would be where g prime, especially for a minimum, changes negative to positive. And I've already said that g prime is equal to f, so I don't need to repeat myself here. Now, if you need to write it to sort of convince your brain that that's what you're looking for, that's fine, but you don't need to say it, because you already told the grader that g prime is f, and now it's sort of on the grader to make that substitution when he needs to, or she needs to. So where does g prime, in fact, some people would even do this, f is equal to g prime. Where does g prime change from negative to positive? Yeah, so if you're shaking your head like that doesn't happen.
G prime changes from negative to positive. 2. X equals 2.
Not from negative to positive. So nowhere. So, and I think that makes sense. Like from 0 to x, we're adding area as we move left to right. We're adding area, so our function g is increasing. Then we're subtracting area. So the graph of g, not that we're good enough to sketch a graph, but it increases up to x equals 2, and it decreases after that. What those values are, I have no idea. Okay, so I only have to worry about the endpoints. And the endpoints are -1 and 5. So they want me to do some work to find g of -1 and g of 5. And I know they make the AP test hard, but they almost always throw you a little bone here and there, because what's g of -1? We already found that. So, I mean, we have to know it, but we already have it. It's -1. G of 5 that we already found, that's pi minus 4. And we're looking for the minimum, the minimum value. Uh-oh, which one of those is smaller? -1 or pi minus 4? Yeah, -1. Because pi minus 4 would be not as negative as -1, right? 3.1 minus 0.4. So what's the answer to the question then? The minimum value, is that the x coordinate or the y coordinate? Value would be the y coordinate. Well, you got lucky. You could get them backwards on this one and be fine. So the minimum value of g is -1, and it didn't ask for it, but if you wanted to specify, that happens at x equals -1. Part D. Find the x-coordinates. Oh, I see what we're doing here. So part C, if you're really paying close attention to this AP, I'm sure this was an old AP question. Part C, yeah, you did a whole lot of work, but basically they were asking for a y value. Part D, they're asking for an x value. Find the x-coordinate of each point of inflection on the graph of G, -1 to 5. Justify your answer. Let's justify our answer first. What is the point of inflection? We know it's something with G double prime. Change of signs. G double prime changes signs. And what is G double prime? We said this already, but I'm going to put it right here. G double prime is F prime. I don't have anything about F prime,
But that's the slope.
but that's the slope of F. So I don't slope of F. So what I'm looking for then is where the slope of F changes signs.
Zero.
So just for in terms of, you absolutely must say G double prime changes signs
For justification.
for justification. The other two things, you don't need to say those other two things because you've kind of already said them. But if it helps you to write it out, to force your brain to like focus on what you're looking for, then by all means write it out. So I'm just looking for the slope of F changes signs. Yes, x equals 0, definitely. Anywhere else?
X equals 3.
And x equals 3. That kind of free response question, super common on the AP test. AP test has 6 free response questions. I mean, I don't know if it's more often than not, but I feel like there's at least a 50-50 shot that there's one where there's a function defined by an integral, because there's so much they can do with it. They can test to see if you can actually find an integral. It's got maximums and minimums and second derivatives and first derivatives, fundamental theorem of calculus. Like, there's so much they can do with this type of problem that it is just very common to see those on the test. And we'll practice a bunch of them, and you should hope you see one of those on the test, because usually you should get most of the 9 points on that type problem. All right, we can work some of these together then. We got some time. Here's my suggestion for worksheet 4. I have it listed for 3 days, but my suggestion would be today do 1 through 15 and 28. 1 through 15 is multiple choice. 28 is a free response. And then tomorrow is, again, mostly multiple choice and some free response. And if you follow that pattern, excuse me, you'll have them all done by Monday, and Monday we can just work on them, rather than splitting it up over 3 days and then you working some of them Monday night but not having a chance to ask questions on them. So I don't care when you do what, but I would strongly suggest you have worksheet 4 finished by Monday. That way we can ask whatever questions we need to on it. So, with time left, let's look at worksheet 4. Uh, 28 is really similar to the one we just did. Again, that's not required. I'll never know how many you do when, but that's my suggestion, is how to split them up. Oh, let's see. Is there anything on there? Looking at 1 through 15 and 28. I'm definitely not going to do 28 because I want you to try 28. That's
Do it tomorrow.
Let's see. Why don't, let's see, what do we want to do? Try the first two. We'll just start off and you'll do some and then I'll work them and then we'll just go back and forth and see how far we get together. Number 2. Are you okay with me going to this step?
Yes. Yes.
You are. Are you okay? So I'm going to pull the 2 out front.
Yes.
And just sort of split these up because this is what I'm trying to find, to figure out what that's equal to. So 2 times whatever that is plus the integral from 2 to 3 of 3 is equal to 17. Well, this part I can do. I can do this because that antiderivative is 3x, and then from 2 to 5, I didn't show much work there, but if I plug in 5 and plug in 2, that's 15 minus 6 is 9. And so I still got 2 of those things, and I stopped writing it. I just said, my red box there. So 2 of those things plus 9 is 17. And so I turned it into, once I did this, now it's just a little bit of an algebra problem. Subtract the 9, divide by 2, and get 4. But that key step was the 2 first steps. Being able to split it up and being able to evaluate by hand this guy. And not trying to evaluate this guy because we don't know that guy. We're just solving for that guy. Questions on either one of those? All right. Try number 3. Trapezoidal sum. But it doesn't want, like a trapezoidal sum estimates an integral, but it doesn't ask you for the integral. It asks you for the average level of cholesterol. So it's asking you for an average value. So I would write the average value equation first and then figure out exactly what piece of the average value equation a trapezoidal sum will estimate. Because it's not just the trapezoidal sum, there's more than that. You can't just do a trapezoidal sum and that be your answer. So write the equation for an average value and then figure out how a trapezoidal sum could help you.